Hello everyone. So in the last class, that is in the lecture 4, we have seen about the series capacitor compensation, shunt reactor compensation and synchronous phase modifier compensation. So these three things we have seen, that is in the methods of voltage control. So how we are going to control the voltage with the help of shunt reactor and with the help of series capacitor and with the help of synchronous phase modifier. So we have seen these three methods. So with the help of these three, we can control the voltage. Either it may be absorbing the reactive power or by injecting the reactive power into the line at the receiving end. So we have controlled the voltage with the help of those three devices. So if we go for the next device, that is in the lecture 5, we are going to see, that is about the tap changing transformers. There is a tap changing transformer and there is a booster transformers. So with the help of that tap changing transformers and booster transformers, we are going to see how the voltage is going to be controlled. So in the last class, we have seen that there is a synchronous phase modifier. So why it is given the name as synchronous phase modifier? Because that synchronous phase modifier can be used as a shunt reactor as well as shunt capacitor. So shunt reactor means which will absorb the reactive power. Shunt capacitor means which will inject the reactive power into the line. So we are having the two devices in one single device. That means there is a shunt capacitor and shunt reactor. Those two devices will be incorporated in a single device called synchronous motor, which is operated under no load. So that is what we have seen. So that will there is a shunt reactor. Shunt reactor will convert leading wires into the lagging wires. That means the power factor is going to be changes here. And then you are having the shunt capacitor. That shunt capacitor, what it will do? That will brings lagging wires into the leading wires. So that means there is a two operations are going to be present. That means there is a change in the angle. That is a phase angle change is going to be present. So that it is given the name as synchronous phase modifier. The phase angle is going to be changes. The phase angle between the voltage and current is going to be changes here. So that is given the name as synchronous phase modifier. So if you go for this lecture, in this lecture we are going to see about the learning objectives. First, if we see the learning objective of this lecture, so that is to understand the off-load and on-load tap changing transformers. So how these tap changing transformers are going to be works? Off-load tap changing transformer and on-load tap changing transformer. So there are two tap changing transformers are going to be present. So how these tap changing transformers will change the voltage. How this is going to be changes the voltage we are going to see. So the next one is to understand the booster transformer which is connected in the transmission line. So we are having booster transformers. So that booster transformers are used to control the voltage. How these booster transformers controls the voltage in a transmission line connected. So that we are going to see in this lecture. So if we go for the first topic, that is in this lecture, the first topic is tap changing transformers. That is the fifth one in the methods of voltage control. So it is commonly employed where main transformer voltage needs to be controlled. So there is a tap changing there is a tappings are provided on the secondary of a transformer. The primary of a transformer is given with the main supply, that is with the some voltage, that is a fixed voltage we are going to give there, and then you need to change the voltage at the receiving end side or at the secondary side of a transformer. So at the secondary side of a transformer, we are going to provide the tappings in order to have the change in the voltage. That is what to control the voltage, we are going to provide the tappings on the secondary of a transformer. So by changing or by controlling the tappings on the secondary of a transformer, we can achieve the voltage control in a tap changing transformer. In a tap changing transformer, we can achieve the voltage control by controlling or by changing the tappings which are provided on the secondary of a transformer. So there are mainly two types of tap changing transformers are there. The first one is off-load tap changing transformer and the second one is on-load tap changing transformer. So depends upon the switching on and off of the load, we are going to divide these tap changing transformers into the two. That is off load tap changing transformer, and the next one is on load tap changing transformers. So we will see one by one these two transformers. The first one is off load tap changing transformer. How this off load tap changing transformer is going to be works? So here, in order to change the tapping positions from one position to the other position. So if you consider here on the secondary side of a transformer, if you see, so you are having the tappings that is from 0, 0%, 25% and 50%, 75% and 100%. So like this you are having the number of tappings on the secondary side of a transformer. So if you want to change any position from 0 to 25% or from 50 to 75%, like that, if you want to change any tapping positions, that is from one position to the another position, if you want to change, you need to switch off the secondary first. You need to switch off the secondary winding. Then you need to change the position from one point to the another point, or one stud to the another stud. You need to change the position, and then you have to switch on again the secondary side. That means there is a discontinuity in the supply to the consumer. There is an interruption of the power to the consumers is going to be available in the off-load tap changing transformer use. So if we use the off-load tap changing transformers, there is an interruption of the interruption of the power supply to the consumers. So that is one drawback here. So in this, on the secondary side of a transformer is provided with number of tappings. As the position of the tapping is varied, hence output voltage of the secondary is going to be varied. That means we can change the output of the secondary by changing the tappings of the positions of the secondary. So that is what the off-load tap changing transformers. So let us consider the case that I am moving or I am changing the tap position from 50% to 75%. So how this is going to be happens in real time. So if I consider the transformer is having the rating of 500 by 1000 kVA. So that is 500 by 1000 volt. Yeah, step up voltage, step up transformer, let us take. That step up voltage is from 500 to 1000 ohms. That means, so you are having the percentage of the studs you are going to have here, that is from 0%, 25% and 50%, 75, 100. That means 0 means 0 volts, 25 means 250 volts, 50% means, so there you are having 50%. That 50% means 500 volts, 75% means how much? 750 volts, 1000 means 100%. So like that you need to divide the tappings. You need to change the tapping positions. So let us take at the secondary side. Here the first case is 500, at the 500 volts it is there. So from that 500 volts, that is from 50%, I need to change it to the 750 volts. So I need a 750 volts of the secondary output. So in order to get that secondary of 750 volts, I need to change that tapping position from that mobile arm must be moved from 50% to the 75%. So in order to move that, what I need to do is, I need to switch off the secondary first, then I need to move the position of the stud or whatever we call the mobile arm from 50% to the 75% I need to change. After changing that to the 75%, I need to again switch on the load, that is on the secondary side I need to switch on. So that only I am going to have the supply to the secondary side. So what happens is, there is an interruption of the supply for a short duration is going to be available in this off-load tap changing transformer. So that is what the drawback of this off-load tap changing transformer. So we can control for variable voltages here. So as we are changing the mobile arm from the one position to the other position, we are controlling the voltage in the secondary side. We are controlling the voltage in the secondary side. So if we see the disadvantage, so here the main disadvantage of this off-load tap changing transformer is that it cannot be used for the tap changing during load is switched on. So if the load is switched on, what happens? So if I move from one position to the another position by switching on the load, so what happens means, suppose let us change the condition. So here suppose for a moment that tapping is changed from position 1 to the position 2 when the transformer is supplying a load. So as the supply is switched on in the secondary side, so I am moving the position of the 1 to the another position. The mobile arm is moved from position 1 to the position 2. Let us take that is from 50% to the 75%, let us take. Then what happens means there are two conditions you are going to present. So that two conditions are, if contact with the stud 1 is broken before contact with the stud 2 is made. So what is that means? If contact with stud 1 is broken, that means as it is moving from that stud 1 to the stud 2, what happens is before the contact is broken from that stud 1, so if it is connected to the stud 2, right, before breaking that contact with the stud 1, if it is in contact with the stud 2, there is a break between the two studs. That means there is an interruption of the supply, but the voltage is present between the stud 1 and stud 2. So between the two tappings there is a voltage is going to be present. That voltage will result in arcing. There is an arc is going to be formed in that gap. So if the contact with stud 1 is broken before the contact with stud 2 is made, before it is connected to the stud 2, then there is a break in the circuit. So that will result in the arc. There is a formation of the arc is going to be present. So and the next condition, if I see, if contact with the stud 2 is made before the contact with the stud 1 is broken. If contact with the stud 2 is made means, so what I am doing is just I am trying to connect to the stud 2, but before it is breaking the contact with the stud 1. That means as it is connected with the stud 1, so you are connecting with the stud 2. There are two connections are going to be present here. That mobile arm is having the connection with stud 2 as well as stud 1. Both it is connected together. Then what happens? The coils connected between these two tappings. What are the coils which are connected between the two tappings? If you see here, so if we from 50% to the 75%, there are two coils are connected. So those two coils are going to be damages. That means those two tappings are going to be short circuited, and which will cause or which will carry the damaging heavy currents. Which will carry the heavy currents that will damage your total winding also. So this, in order to overcome this disadvantage, we need to vary the secondary winding tappings by switching on the load. That means we need not to provide the discontinuity to the supply, to the consumers. That means we have to provide the continuity of the supply to the consumers. Our main electricity power system aim is to provide the continuity of the supply to the consumers. So in order to change the tap positions, if we disconnect the supply to the consumers means there is an interruption, there is no reliability to the consumer. There is no trust on the electricity supply or distribution departments. So that means in order to have the reliability, in order to have the continuity of the supply to the consumer, we need to change the tap positions by switching on the load. So that is what the second case, that is on load tap changing transformers. By connecting the secondaries to the load, we are going to change the positions of the primary as well as secondary. So that means only secondary we are going to change. Whatever the primary voltage is there, that is imposed on the secondary side, that secondary voltage is going to be changes by changing the tap positions. So in this we are having a tap changing has a normally, in this tap changing has normally to be performed on the load, so that by connecting or by switching on the load, so that there is no interruption of the supply to the consumers. That is the main aim. So here what happens is, here you are having two windings are going to be present in the secondary side. So in order to provide the continuity of the supply, we need to have the two windings. Those two windings are connected together. So the secondary of those two windings are connected at the below, that is at the bottom. You are having the two connections, and on the top of these windings, the tappings are going to be provided. And the two windings, the tappings are going to be provided. So with the same number of studs, that is 1A, 1B, 2A, 2B, 3A, 3B, 4A, 4B, 5A, 5B. So like that you are going to have the tappings on the secondary. And you are having the two main switches for the one winding and the other winding, that is A and B. There are two switches are going to be present. So by opening or closing of that switches, we can control the tappings of these positions. So that is what going to be happens in this on-load tap changing transformer. So here, so there are two windings are going to be present in the secondary. So those two windings will carry half of the total rating of the secondary. So whatever the secondary voltage is there, so that secondary voltage is going to be divided into the two halves, and each winding will carry the half of the rated value. So but the case when, let us consider how it is going to be changes the tap positions. So let us consider that there is a position A and there is a position B, that is switches A and B are there. So just I am having this secondary transformer is working on the 4A and 4B switches as this condition. Let us consider the condition that this secondary is working on the 4A and 4B. So I need to change that positions of 4A and 4B to the 5A and 5B respectively. So how the changing of that is going to be happens means, so if I want to change the position of the 4A to the 5A, I just need to open the switch A. That is switch A I need to open, and then the other winding, you are having the winding B. So that winding B will carries, when the switch A is opens, the other winding B will carry the total rated current of the secondary winding. That means twice its rated value. So actually its rated value of that single winding B is half of its rated value of the secondary. But when the switch A is opened, it will carry the total secondary current. It will carry the total secondary current, that is twice its rated value, twice the rated of the B winding. That means 2 times. So that will only for short duration of time. That will not damage the total secondary B winding, but it is only for short duration of time. Right. So I am opening that switch A. Then by opening the switch A, you need to move the position, open the 4A, and you need to close the 5A. By opening 4A, you need to close the 5A. Then again you need to close the switch A, that is main switch you need to close. First what I am doing is just opening the switch A, main switch. Then I am opening the 4A switch, which is already previously in contact with the winding. Just I am opening that. Then I am closing the 5A. Then main switch is going to be closed. That is main switch is A is closed. In the same way, again I need to open the B. Then what happens, the A winding, whatever the winding A is there, so that winding A will carry the twice its rated value. That is the total secondary winding, secondary rating is going to be carried by the A winding when the B switch is open. So here what happens, by opening the switch B, what I am doing is I am opening the 4B, then closing the 5B. Again I am closing the switch B. So in this way I am changing the tappings without interruption of the supply to the secondary of a transformer. By opening and closing of the switches of main switches, we are changing the positions of a transformer from one position to the another position. So if I want to connect, if I want to have the minimum voltage on the secondary side, then I need to connect switches 1A and 1B should be closed, and A and B main switches should be closed, so that you are going to have minimum voltage of that rating of the machine. Whatever the minimum voltage is there, that is on the secondary side, that you are going to present on the secondary winding. That is at the load side you are going to have. So if I want to get the maximum voltage, so where I need to connect this to the maximum voltage? That means by closing that switches A and switch B you need to close, and then you need to close the 5A and 5B. Those two positions if you close, phi A and phi B as well as A and B main switches. If I close, then you are going to have maximum voltage on the secondary of a transformer, that is on-load tap changing transformer. So there is a disadvantage in this on-load tap changing transformer also. So during the switching operation, what happens is the impedance of the transformer is going to be increases. So during the switching operation, the impedance of the transformer is going to be increases, and there will be a voltage surge. Voltage surge is going to be present, and then you are having there are twice as many tappings as the voltage steps. That means what you are having here, two windings are required in the secondary side, but whereas in the off-load tap changing transformers, you are only requiring one winding in the secondary. But whereas if you come for the on-load tap changing transformer secondary winding, so that secondary winding will having two windings, that is A and B windings. That two windings are required. That is, there are twice as many tappings as the voltage steps. So here you are having only, in the first case you are having only one side tap changings, but here two tap changings are required. Two windings are there, two tap changings are there. That means you are having high cost. Cost is also increases, right? So if you go for the next one is booster transformer. Booster transformer is nothing but what? So that booster transformer is used mainly in the transmission lines. So when it is designed to control the voltage of a transmission line at a point far away from the main transformer. So main transformer is present at the let us take at the generating station. You are required to change the voltage at far away from the main transformer. So at that particular locations of time, or at that particular locations, we are going to use a booster transformer. So in order to have the fine tuning of the voltage, we are going to use booster transformer. So whereas you are having the tap changing transformers or auto transformers, those auto transformers or tap changing transformers will not provide a fine tuning of the voltage, but whereas booster transformers will provide the fine tuning of the voltage up to 231 volts. If you want to keep, you can keep by 231 volts by using booster transformer. But if you use the auto transformer will change 230 to 233. In between that, the value is going to be varies. It is not going to be stop at particular location. So as we have seen in the power system lab, that as we are changing the tappings of the, that means auto transformer start as we are moving, then what happens? It is moving and we cannot able to fix the point of the voltage, that is at the 230 volts we cannot able to fix, but it is changing from 230 to 233 or 234, like that it is going to be changes. The fine tuning is not going to be available in auto transformer. So when you go for the booster transformer, you can have the fine tuning, how much value you need to keep, you can keep by using booster transformer. So that is the advantage of booster transformer. So here we are connecting booster transformers in the line to be control the voltage. Where you need to control the voltage, at that line you are going to connect this booster transformer in series. So here we are using the main three transformers we are going to use. First one is a main transformer, another one is a regulating transformer, and there is a booster transformer. So that booster transformer is used in series with the line. So we are going to connect in series with the line. So in general, in practical cases, we are going to connect a main transformer. The main transformer is provided with the secondary tappings, and then we are going to be transmit the power through a feeders or transmission lines. Then at what the condition at where we need to change the voltage of this, we are going to place a regulating transformer there. So there we are going to use the regulating transformer. So that regulating transformer is provided with the secondary tappings. So for the primary of the regulating transformer, we are going to connect a booster transformer which is in series with the regulating transformer primary. And for the secondary of booster transformer, we are going to provide the connection from the tappings of the regulating transformer. we are going to provide the connection of a secondary of a booster transformer with or from the regulating transformer secondary, that is tappings. Tapped secondary of a regulating transformer. We are going to provide the booster transformer connection. So then we are going to have the load at the positions B and B. And at positions A and A, if you see here A and A, at that positions A and A, you are going to connect the transmission lines. Again, then there is a regulating transformer. After that regulating transformer, you are having the booster transformer that is connected in series, and then you are having the positions B and B. Then for that B and B, you are going to have the load. Load is connected. Where you need to change the voltage, we are going to connect the booster transformer. The fine tuning of the voltage is going to be available with the help of booster transformer. So you are using booster transformer. So here, how the voltage is going to be changes. The voltage changes is going to be happens means, so there is a main transformer. So this main transformer tappings are going to be changes. How much voltage we need to change? So that main transformer tappings are going to be changes. Then that is reflected change on the regulating transformer. So that regulating transformer is having the tappings on the secondary. So how much voltage you need to kept? By changing that, we can have the fine voltage by the booster transformer tapping change. Tap changes by the booster transformer, we can have the fine tuning of the voltage is going to be available on the load side. So you are having the load is connected at the B and B positions. So by connecting the load, we can achieve the fine tuning of the voltage to the load. So that is what the regulating transformer and booster transformer. So from the positions A and A, you are having transmission line, and then you are having regulating transformer, then there is a booster transformer. So this booster transformer will inject the voltage into the line. The booster transformer will inject the voltage into the line. So then what happens, that is that voltage is in phase with the load voltage. Whatever the voltage is there, that is in phase with the voltage. Right. So that is what your booster transformer. So there are some disadvantages of the booster transformer. If you compare with the tap changing transformer, you are having some disadvantages. So it is more expensive. Why it is more expensive? Because we need to have 3 transformers. So there are 3 transformers are there. Main transformer, regulating transformer and booster transformer. The cost of this is going to be increases because of using of 3 transformers. So that means more expensive when compared with the non-load tap changing transformer. So it is less efficient due to the losses in the booster transformer. So there is a booster transformer is there, there is a regulating transformer is there. So these booster transformer and regulating transformers are having inductance in that. So that inductance will consume some amount of the voltage, so that we are going to have some losses. There is a resistance is there. So that resistance will cause for the losses in the winding. So that losses will cause for the efficiency reducing. That means less efficient due to the losses in the booster transformer. And you are requiring more amount of the floor space, because you need to place the 3 transformers. So for that 3 transformers, you need to require more amount of the floor space. That is, more floor space is required. So that is what the disadvantage of this booster transformer. So with this total, we have completed the receiving and voltage control. So we have seen total 6 methods. That is, the first one is shunt capacitor compensation, next one is shunt reactor compensation, and the third one is we have seen series capacitor compensation, and the fourth one is synchronous phase modifier, fifth one is tap changing transformers, and the sixth one is, the last one is booster transformers. By having these 6 different methods, we can control the voltage at the receiving end side. That is, receiving end voltage control is completed with this, and then we are going to see about the sending end voltage control. So in that sending end voltage control, we are having generated excitation controller. So that the generator excitation controller we are going to see in the next class. So if we see the summary of this lecture, so what we have seen is, we have seen the off-load tap changing transformer. These off-load tap changing transformers cannot be used while the load is switching on. While the load is switching on, we cannot use this. So with this, there is a power interruption is there. There is a power interruption to the consumers. So on-load tap changing transformer we have seen. So that on-load tap changing transformer can be switched on or can be operated or can be changed the positions by or during the load is switched on. So in the last we have seen the on-load tap changing transformer. In that we are requiring there is a disadvantage in that on-load tap changing transformers. So that is there are tappings. Two windings are going to be present. That will have the two number of tappings. That is 2 times tappings are required. That is 1A, 1B, 2A, 2B like that. There are two times of tappings are required. So that will increase the cost when compared with the off-load tap changing transformer. And then we are seeing booster transformer. So these booster transformers are used to control the voltage in the transmission line, which is from far away from the main transformer location. So main transformer is presented at the generating station. So from that main transformer, the voltage control position is going to be very long or far away from that distance. Then we are going to use booster transformers. So in order to get the fine tuning of this voltage, we are going for the booster transformers. So for this I concluded class. So thank you everyone. Thank you for listening this class.